Welcome to Plotting Data for Finance 372. For data analysis to be truly effective, you need to communicate the results to other people. Plots can be a very powerful tool for communication, helping your audience both understand and remember the results. They can also help the data communicate with us by showing new patterns or connections we wouldn't have otherwise noticed. Because plots are inherently designed for conveying information clearly, designing and formatting them well is extremely important. In fact, as you'll see in this video, creating a plot takes only a few lines of code. The tough part is formatting it so you and your audience can understand and learn as much as possible. The library we'll use for plotting data is called matplotlib. So if you haven't already installed it, use pip install matplotlib to get it up and running. So for this project, we want to import matplotlib.pyplot and .dates. We'll name them PLT and mdates respectively. So for this project, I downloaded some COVID data for us to have a look at. So let's load that into a data frame using readcsv, and let's change the date column to be a date time column, and let's have a look at the data. So as you can see, this data has stuff from different countries, different dates, total cases, new cases smooth, deaths, etc., etc., etc. All right, so for us, let's focus only on the US data. So let's just grab a subset of this data frame that has the location column equal to United States. So if we run that, now we can see that we only have United States data. So now let's get plotting. The way you set up a matplotlib plot is with two standard commands. You create yourself a figure by using fig equals plt.figure. Then you create yourself an axes, which are the axis inside of a figure, by using fig.add_subplot. And then we just need to tell it that we want a 1x1 grid of subplots, and this will be our first subplot. All right, now that we have our figure and axis set up, we can actually plot the data. We can say ax for our axes.plot, and then we give it an x and a y. So the x is our x data for the x-axis, and y is the y data. So in this case, let's just try plotting the number of new cases each day, and we'll use the smooth data. Okay, so for that, we need the x-axis to be the date column, and the y-axis to be the smooth new cases column. So this code alone will create a plot for us. So let's run it and have a look. So you can see here that we've plotted our number of cases as they evolved over time. And it's nice. We can sort of see what we want to see here. But there's a few things we'd like to improve about it in terms of formatting. The first thing is that everything is sort of small here. So let's try to make the figure a little bit bigger. The way you do that is you go back up to this command here, and you tell it that I want my size to be bigger. The command for that is fig size equals, and then you give it two parameters, 20 and 10, let's say. You kind of just have to play around with these parameters to figure out the right sizes. Now if I rerun this, you'll see a much bigger plot. So this is width and height. Now that we've made the plot a little bit bigger, we might want to make the font sizes a little bit bigger because these are a little bit small to read, especially if you imagine printing this out on a piece of paper. So let's make the font size a little bit bigger. The way you can do that is using these command plt.rc, and then so the way this rc command works is it lets us change lots of different properties all using this one rc command. And we have to tell it two different things. One is we have to tell it what category of plotting object do we want to change. So let's start by changing the x ticks. What are x ticks? Well, there are these little ticks right here on the x-axis, and what we want to do is change the size of the font on these labels right here. All right, so then we can do that by doing label size equals, let's make it 14. So now if we run this, you'll see that the labels are bigger here, much easier to read on the x-axis. Okay, now we can do the same thing with the y-axis. Run that, and again we have now bigger labels on both the x and y-axis. So one problem with this figure as it stands right now is it doesn't tell you what it's plotting. These x-axis is clearly time, but what is the y-axis? All right, so first let's give it a y label. To do that, we talk to the axis and tell it to set y label, and let's label this new COVID-19 cases in the US. All right, so now we have that label there. Let's also add an X label. All right, so as you can see, we added these labels, but these also have now really small font sizes. So to make these fonts bigger, we need to go back up to our plt.rc command and do plt.rc axis label size, and we'll make it a little bit bigger than the tick labels. We'll make it 16. The way this axis command works is it works on both y and x axes at once. Okay, and you can see once we had done this, the axis labels are a little bit bigger and easier to read. Now maybe we should add a title to this figure so readers know right away what they're looking at. The way we do that is with the axis.setTitle. Let's just say a year of pandemic. We run that and we see we have a title up here. Again, the font is small. To change the font size, we need to go to our plt.rc and tell it axis. And then instead of label size, we say title size. Let's make that even bigger. Let's make it 18. All right, so now we have nice labels here. We know kind of what we're looking at. There's still some things that are a little bit ugly about this, though. One thing I don't like is that it seems to start and stop in the middle of the plot. It would be nice to have these axes a little tighter around this. So we can do that by manually setting the axes limits. All right, and I'm mainly focused here on the x limits. The y limits look pretty good to me. So let's do ax.set xlim. And then we need to give it two commands, which is the lower and upper. For the lower bound, let's just use the minimum date in our data frame. tf.loc date, and then we can just say min. And then we'll do the same thing to get the maximum date in our data frame. So now we update our plot, and you can see now that the axes are tight on this side. They're not actually quite tight on this side. The reason for that, if you go back up to our USA data, we have some days at the beginning where we have dates, so it's in the plot, but the cases are missing because when we're trying to do this smoothing, we haven't had enough days yet with positive cases for this smoothing to work. So we have these missing values here. All right, so to prevent this, what we can do is to set our y limit to not just the minimum date period, but the minimum date where tf.loc new cases smoothed is positive. So that will check to make sure it's not missing. So if we run this now, you get a tight x-axis on both sides. These x-axis labels look pretty good to me, but I just want to show you how to change them anyway. So let's say we want to make it go every other month instead of every month. Or let's say we want to make it say March 2020 instead of 2020-03. We could do that as follows. First, let's change xticks to be every other month. So the way we do this is we need to tell the x-axis to use a new locator. Locators are what this library calls the function that tells you where to locate the ticks. We write ax.xaxis, and then we tell it to set major locator. So this is a major locator because these are the major ticks, the ones that have labels. I'll show you in a second how to add minor ticks. So for this, we want to tell it to use an every other month locator. The locator we want to use for that is in the mdates library, which is, again, to remind you, is the dates library within the matplotlib package. All right, inside the mdates, there's something called a month locator. There's also a bunch of other locators you can use inside here. But month locators will locate the ticks at monthly intervals. So I'm going to tell it interval equals 2, and that will make it every other month. So now if we run this, what we should get here is an every other month major ticks. But now let's say we want to add some minor ticks where we have an unlabeled tick in between each of these for every month, but only the every other months are the ones that are labeled. To do that, we do ax.xaxis .set minor locator. And now we can use the same month locator, but now our interval will be 1. And you can see this gives us these little minor ticks right here that tell us that these are the months in between. All right, last, let's see how to format these things. So let's say we want to have this say March 1st. So the way you change the format of the text on your labels is using a formatter. So like we used a locator to tell it where to locate the ticks, the formatter tells it how to format the text that lands there. So again, we're going to go to ax.xaxis. And we'll use, instead of set major locator, we'll use set major formatter. And then for our formatter, we'll use, again from mdates, something called a date formatter. So the way you tell it how to format your dates is by giving it a formatting string. So these formatting strings have different codes in them that tell Python when to use the year, month, day, hour, minute, whatever you want to tell it. The way these codes always work is you put in a % and then a letter. So %y we'll insert the year there. So if we want, instead of having be 2020-03, we can have be 2020/03 for the month. So if we run this, you can see that the only thing that changes is we add this little slash here. All right, but we're going to make a bigger change here. We know it's 2020 or the start of 2021, so we don't really need to say the year here. So let's instead just say month, but let's have Python spell out the first 3 letter abbreviations. So MAR instead of March or 03. The code for that is parentheses B, And then let's have it tell us the day too. That will be %D. If we run this now, you can see we have March 1st, May 1st, July 1st, September 1st, etc. All right, so that's a pretty good looking plot now. I'm sort of happy with how that looks. Let's go on to do something a little bit different now though, and let's look at cases and deaths side by side. So now we want to have 2 lines in the same plot. So to do this, let's copy our first 3 lines of code up here that create the plot and paste them down here. Okay, now since this is a new figure, we need to tell it this is figure 2. Give it a different name than we had before. Same with the axis, and then tell it axis2.plot. All right, now we need to add a second column to our y variable in this plot command. So it tells Python to plot both new cases and new deaths side by side. So the way we do that is using another square brackets here, and to tell it we also want new deaths smoothed. So now if we plot that, we get the same kind of graph we saw before for new cases, but we have this green line here of new deaths that you can barely see how it's moving. That's because it's on such a different scale. There's less than 1% of the cases turn into deaths. So we have a good instance for using a log scale on the y-axis instead of a linear scale, right? Because then we'll be able to see movements in both these things side by side. In general, in finance, you'll also want to use log scales when you're talking about long time series of compounded returns, because then you can see an exponential growth thing turns then into a linear graph. So how do we turn this into a log y-axis? Well, in Python, it's pretty easy. We can go back to our PLT command and choose y scale and set it to log. Notice here that our previous PLT commands, the one that set the font size here, have all carried through because those commands affect all subsequent plots. So we run this now. We get the same plot, but now looks pretty good with these logs, but we have all this weird stuff happening here at the beginning. This is because we can't do the log if we have 0 or missing values for deaths or cases. All right, so we have all these weird averages where you had one case and then it disappeared. So let's just start our plot here at March 1st. So how do we do that? We can go to our xlim command like we did before. The way ax2.setxlim. All right, now what we did before is we just told it to use the minimum date, but now I'm going to tell it to use a specific date. So how do I do that again? Well, I can just type the date in a string this way. It's the easiest way to do it. And then for our maximum, let's just still stick with the maximum value in our data frame. So now if we run it that way, we get a much nicer beginning here because we're only starting in March 1st. And now we can see how this has changed over time. We see that that green line, which we could barely see before, is actually following a very close, very similar trend to the blue line, because we all know that cases are proportional in some sense to deaths. All right, finally, let's copy and paste some of our flavor from above, the labels of everything, because those are going to stay mostly the same. We need to change all the AX references to 2. And we run this and have a look. You can see now we have our labels again. Now for this plot, though, the Y label doesn't quite make sense anymore. This is not new COVID cases anymore. So let's just actually remove that Y label, and let's replace it with a legend instead. A legend is a sort of box within your plot that labels each of the different lines that you have. All right, so the command here is ax2.legend, and then we need to just tell it what the 2 labels are. It applies those labels in the order that you gave the original data. So for us, cases are first and then deaths. So we can do new cases in US smoothed, and then we'll do the same thing for new deaths in the US smoothed. All right, so let's have a look at that. As you can see, we have this nice label up here for what these lines mean. Now, again, we have a small font size. That's because the legend has its own font property, so we need to tell it that that size needs to be big as well. So for that, we can just do, in our legend here, we can just have a quick command, plt.rc legend font size equals, let's make it 14. All right, and we have a nice readable legend here. We have cases and deaths. As you can probably guess, there's a million more ways to customize these plots and make them show exactly what you want. There's different kinds of plots. You can do bar graphs, you can do pie charts. All of that is sort of a trial and error experience, unfortunately. You have enough here to get started, and then I encourage you to look at the links inside of this sheet for the proper documentation, and then Refer to your friend Google when it's time to create a new kind of plot that you're not sure how to do.